The other class of organic compound is called alkanoic acids or carboxylic acids. Organic acids or carboxylic acids. That is the class they belong to, and they contain an alkyl group. That is, they contain an alkyl group, COOH. This is the alkyl group. The way alcohol contains OH, alkanoic acid contains COOH, which is C double bond to oxygen and to OH. Then R standing for alkyl group. The alkyl group means the number of carbons. It depends with how many number of carbon it has. That is the structural formula of carboxyl group that forms carboxylic acid, COOH. That is the carboxylic group. Now when we come to naming them, now we have the one with one carbon. This is from the one methanol. It's called methanoic acid. This methanoic acid, 1 carbon, 2 carbon, ethanoic acid, 3 carbon, propanoic acid, 4 carbon, butanoic acid, 5 carbon, pentanoic acid, 6 carbon, hexanoic, 7 carbon, heptanoic, 8 carbon, octanoic, 9 carbon, nonoic, and decanoic with 10 carbon. That's how we name. So we realize that the general formula for alkanoic acid, for carboxylic acid, it is CnH, 2n plus 1, then COOH, the carboxylic group, that way. Such that when I have C20, then H takes 20 times 2, 40 plus 1, 41, then COOH. When I have C6, then H is 6 times 2, 12 plus 1, 13, COOH. That is now how we draw or name alkanoic acid. We can also do the molecular formula, whereby you combine the N. You combine the carbons in that, and you can write the molecular formula like this one would be C. There are 6 plus 1, 7, then H, 13 plus 1, 14, then O2, it's carbon with 7. If it has this decanoic, then it will be C10, that is 10 times 2, 20, 21, 7 times 2 is, that is times 2, H, 20, O2. When we have C9, H, 9 times 2, we get 18, O2. That is how we draw that. If with C6, we have C6, H, 12, 0, 0, 2. 0, 2. Yes, that is how we give molecular formula of carboxylic. The other part we want after naming them, we have said that is the functional group, they are carboxyl group. We name them with OIC at the end. The other thing is preparation. And I'm not repeating this. We have done preparation of alquanic acid. We said we oxidize alkanos. In G, when we have ethanol, we oxidize it to ethanoic acid. And we said we use oxidizing agent which are acidified. And if you are using manganese 7, then it changes from purple to colorless. I may not repeat that one. Because you have checked at oxygen. That is generally how we prepare alkanoic acid. And we are saying we oxidize alkano using manganese 7, which are reduced to manganese 2 that are colorless, and chromate 6 that are orange, reduced to chromium 3 ions that are green. Then, when we say acids, alkanoic acids are soluble in water. That is physical properties. They are soluble in water. And the things that are soluble in water are able to form hydrogen bonds with their molecules. So, molecule of an alkano can form hydrogen bond with water. And their solubility decreases with increase in molecular mass, or it decreases down the group. It decreases down the group as molecular mass increases. This is because of the increase in polarity. Remember the polar solvent? The polarity decreases down the group. Therefore, the solubility decreases down the group. Another property is melting point and boiling point. Melting point and boiling point of alkanoic acid increases down the cells due to increase in molecular mass that increases the strength. There is increase in strength of weak van der Waals forces. So the strength of weak van der Waals forces increases down the group, and that tells you if your butanoic acid has a stronger van der Waals forces than propanoic acid, and hexanoic acid also has a higher melting point than butanoic acid due to increase in the strength of weak van der Waals forces. Alkanoic acid have a higher melting point and boiling point than their corresponding alkanos because they are able to form more hydrogen bond in their molecule. For example, butano and butanoic acid. Butanoic acid has a higher melting point than butano because it is able to form more hydrogen bonds per the molecule than alkano. And now we want to concentrate on chemical properties of alkanoic acid. That is chemical properties. Number one is we say it is a weak acid, alkanoic or organic carboxylic acids are weak acids. And in topic 1, before you say what are weak acids, they don't dissociate fully to give hydrogen ions, they dissociate partially. For example, when we have ethanoic acid, that is CH3COH, and you put it in water, it dissociates to form CH3COO plus an hydrogen ion. You see, not all hydrogen ions have been dissociated. Not all of them. You can see 3 atoms there. So it dissociate partially. You see it is a weak acids, all of them. And they have about a pH of 5. In practical, when you check something and you see pH of 5, you say weakly acidic. Now, another chemical property, number 2, is they react with the metals. So when we have carboxylic acid or alkanoic acid, carboxylic acid plus metal, we get a salt plus hydrogen gas. And this name of salt is metal alkanoid. Metal alkanoid. For example, when we have ethanoic acid, when we have ethanoic acid plus magnesium, we get magnesium ethanoate plus hydrogen gas. When we have butanoic acid plus calcium, we get calcium butanoate plus hydrogen gas. That is another reaction. For example, we write an equation for the reaction between ethanol and magnesium. So ethanol is said the CH3 COOH plus magnesium, and the H is replaced by magnesium, so we have CH3 COOM magnesium plus hydrogen gas. And because of hydrogen gas, that tells you they have to be 2. And because of 2, we have magnesium has a valency of 2. So this goes there, 2. We have 2. And here again, we have 2 to make it balanced. That is the reaction between ethanoic acid and the magnesium to get magnesium ethanoate plus water. So in general we say alkanoic acid plus a metal. Alkanoic acid plus a metal, we get metal alkanoid plus hydrogen gas. The third reaction number 3, is the reaction between alkanoic acid plus sodium hydroxide You have seen this is an acid and sodium hydroxide. We get salt plus water. A reaction we call neutralization. And the name of salt comes from the metal in the base, that is sodium alkanoid. Sodium alkanoid plus water. For example, when we have an acid by the name propanoic acid, we have propanoic acid plus sodium hydroxide, and then we get sodium propanoate from the acid plus water. And the chemical equation is propanoic acid CH3 CH2COOH plus sodium hydroxide. We get sodium propanoate, so we have CH3 CH2COO